Let me try to show you this first part, and another part will follow. We have parabolic functions. So if you didn't watch the first video, please do watch it because we explained some other parts that are very important there. So as we said that on the first video, that each and every parabolic function is represented by its formula. So this is the formula for these are formulas of parabolic functions. It's one the same things that they can be written in different format or in different ways. So we have ax squared. So as you can see, ax squared is mean that the graph, it is not yet translated. It is in its origin part or form. So why do we say that? It's because there's no plus or minus q. So that's why we're saying it is not yet translated. But the other ones are translated up. Why? Because the q's and c are positive. If they were negative, we're going to say these graphs were translated down. Okay, but we'll talk about that. So it's very, very important to know these formulas, or how to solve each and everything whenever you are given this formula or whatever formula but of a parabola. So here we have the value of a and the value of q. We know that when a is positive, it means that the graph is happy, or having a happy face. Let me just remove this Cartesian plane here and use a structure. Okay, if a is positive, it means that the graph will have a happy face. And if a is negative, it means that the graph will have a sad face. Then here we have something known as the turning point, where this structure is turning. It is turning exactly at this point here. And here we say it is the turning point. Also over here, this is the maximum turning point, and the other one of a happy graph is a minimum turning point. Note that. Okay, let's try to move. We have something known now as domain and range. We explained domain and range when we're doing linear functions, so make sure that you go to that video to understand that part. So what you must know, for an example, let's say we are given 3 into x plus 4 squared minus 3. Then here, what they want us to write down the range and the domain. What you must know about domain is that the domain of a linear, the domain of an exponential and parabolic, you write it always in this way. So go and watch the linear function, then you will understand why did we explain it in this way. Now, when it comes to range, what you must understand, we focus on the value of a and we take q. So we focus on the value of a and we take q. We're not interested with what is inside the bracket. So if a is positive, as you can see, it means that y greater than or equal to the q as it is. I hope you understood that. But if a here was negative, it was going to be facing in the right hand side direction. So it was going to be like this if a was negative. Then we take q as it is with its sign. So you must show that inequality equal sign there. That's very important. Now let's say we have this. As you can see here, that the a is positive. You do not use equal sign, inequality symbol. Okay, as you can see that a is positive 9, then it's greater than or equal to 7. But if a was negative, it was going to be less than or equal to. I hope you understand that. So x squared plus 9. Let's just use x squared minus 9. Yes, let's say it's x squared minus 9, or even if it's x squared plus 9, doesn't matter. So here you know that the value of a is 1 and the value of q, the value of a is 1 and the value of q is 9. Therefore we focus on a and q. Therefore a is positive, then we take 9 as it is. Y greater than or equal to 9. So we focus on a and b. So of a and q when we determining what the range. So if you say y is less than and you do not put that equal sign under the inequality symbol, we are no longer talking about a parabolic function but an exponential function. I hope that makes sense. Okay, what else? Let's talk about the turning point. This is very, very interesting, right? So please like the video if it is. So this is the turning point. You must have the coordinates of the turning point. Even this one is the turning point, the maximum turning point, as the turning point is up there. Then y equals a into x plus p squared plus q. For you to find the turning point, you just actually take what is inside the bracket here, then you equate it to 0, then that will be the x coordinate of the turning point. So x equals negative p, then that negative p is the x value of the turning point. You write it negative p, then you take q as it is. So now you're done. This becomes what? The turning point of this graph. I hope that makes sense. So if we have f of x as negative 3 into x minus 4 squared plus 6, what you must do here for turning point, take whatever that is inside the bracket, you equate it to 0, you solve for x. Then that value of x is the x value of the turning point. Then you take 6 as it is the value of q. Then you're done. That's your turning point. I hope you understand this. Second example. Suppose you are given y equals open bracket x plus 2 squared minus 9. Therefore the turning point becomes what? You take whatever that's inside the bracket, you equate it to 0, it will be negative 2 and that 9. So this is the turning point. I hope this makes sense now, guys. So if you are given in this form, it's very simple for you to actually see the turning point by taking what is inside the bracket and you solve for x. That x becomes what? The turning point, the x value of the turning point. Then if you are given something like this, you use this formula. This is the formula of axis of symmetry. And the axis of symmetry, the value of x there is the same or is also the x value of the turning point of a graph. And after finding that, you're going to take what that value of x and substitute it back on the graph of y to find the y corresponding value. But let's actually show you how to do this, and this will be the first part. Second part, I will actually upload it after this one, where I will show you how to answer those questions based on what we've covered so far. Okay, let's try to make an example whereby we are given an axis of symmetry. So let's say we are given f of x as 2x squared minus let's say minus 2x instead of saying x plus 4. Then you can see here we have something known as an axis of symmetry. So you use axis of symmetry to find the x value of the turning point. So let me show you what a symmetry is. In grade 8 or if I'm not mistaken, maybe in grade 7, you were taught, for example, let's say this is a butterfly. Don't mind it, but as I said that, let it click in your mind that this is what is a butterfly. Then we have this red line here as I'm actually showing it. So this red line is known as what? The symmetry. It divides this butterfly into half. So that's what it does even in a parabolic function. Okay, so this is the formula that you use to calculate axis of symmetry. They can ask you in an exam to determine the axis of symmetry, but what you must know is that the axis of symmetry is the same thing as the x value of the turning point. So you're going to use it. We have a, b, and c, as you know. So x into negative 2 into 2, the value of a. Therefore, you use your calculator. You're going to have 2 here over 4. Then the answer is half, 1 over 2. So this is the x value of the turning point. Therefore, you can take this x value of the turning point as it is the axis of symmetry and substitute it back on the graph of f to find what? The y corresponding value of the turning point. Hope you understand that. Let me just repeat. You can take this x and substitute it back on the graph of y. Substitute it back on the graph of f or on the graph of y to find the y corresponding value. So there we're having an unknown value or unknown variable, which is y. So in order for you to find it, use your calculator, take that half and substitute it on the graph of f to find the corresponding y value. Now we have 1 over 2 is to 7 over 2, but you can use your calculator to check if this answer is correct. Let's say we have 2 into x plus 4 squared plus 3. Then here the turning point, it will be positive 4. Actually, inside the bracket it was negative 4x minus 4 squared plus 3. Then the turning point will be 4 and 3 as the coordinates. Then what else? Now sometimes you can be given, for an example, a function like this one as we are dealing with here. You must use what? The axial symmetry. It's not simple that you can actually take what is inside the bracket because it's not actually yet completed. There's something known as completing the square, but you can do it, right? I think you understand this. Very, very important. So you cannot actually take the brackets out here because you don't have them. Just simply use what? Axial symmetry. Now let's say you have x squared minus 9. Now since this is x squared minus 9, it's not similar to this one, and it is not similar to that f of x. But here, you know that the turning point, it will be 0 and negative 9. Why? Because if you can look at this graph when we draw it, so that 0 is to negative 9, it becomes what? It becomes our turning point, because the y-intercept of a graph that is x squared, ax squared minus c, the turning point becomes what? It becomes the y-intercept of the graph. I hope you understand that. So if it is x squared minus any number that's when you put it under a square root, it will give you its natural answer. So it means that it is the function of a difference of two squares. But do not forget it's parabola. So it becomes the y-intercept of that graph becomes the turning point. I hope you understood it. So that's very, very important, guys. So this is how you find the axial symmetry, the turning points, and you must know that even here, what you must understand, 0 is the axial symmetry. The x value of the turning point is also known as the axial symmetry. Please note that. So it's very, very important. Very important. So please like the video. Second part is coming. Thank you so much.